This will be the technical training for the fixture modeling demonstration, looking at using synchronous technology in the NC programming environment. In this case, we'll be leveraging or piggybacking off of the airplane tail example from the CAD assembly modeling materials. What we have here is essentially a custom fixture that's been developed for the original part. We saw in the CAD example that this part has been fit into a new or modified tail assembly. It was edited in place in the assembly environment, matching faces as appropriate, moving things around, making it fit into the new tail. Excellent example of using synchronous technology in a assembly modeling environment. What we'll discuss here and what we'll find is that fixture models in the NC environment are similar to that case, where we have custom assemblies that fit specifically to a part. And just as in the CAD example, we are reusing our assembly and quickly adapting it to the new conditions, we'll do the same thing here. The difference really is just that we are looking at NC personnel, either the NC programmer himself who does this work on a part-time basis, or even a fixture designer in the NC department who's doing this work. So again, the messages are targeted for NC personnel, and really the benefits are going to be similar to what we saw looking at the aircraft tail complete. So just to review here, we have the part itself, which was originally from some other aircraft tail. When it was produced, it was fixtured up on some assembly, and we can see that the fixture assembly itself is not very complicated, but it's a few pieces big. It's been fit to hold it securely and in position, but with the changes to this part, we're going to see how we can reuse this again, similar to what we did in the tail. First thing we have to do with this demonstration is to make the part itself our work part. And you can see that the last couple of changes that were made to this part, which were the movement of the ears here, you remember that we made that change, and then also the width of that spacing. The spacing of that has changed. So the last couple of changes that were made to this part really affect the way it fits into this fixture in a couple of significant ways. So the fixture designer, again, wants to reuse the work that's already been done. He wants to fixture it in a similar way as the previous part. It's kind of the same class of geometry. He just needs his fixture to be updated to this, and he'll use his synchronous tools to do it. So let's start by working on the fixture body. The first thing we need to do is make this whole thing taller. You can see that because the ears have dropped way down, that the whole fixture is not really tall enough to hold this anymore. So we can quickly fix that. And this is a nice opportunity to pick up some of the reference type things that we can do. When we pick a face, we can grab its offsets, which means that we've selected top and bottom together, and then we can simply drag it down until the clearance is sufficient to get out from under that ear. 15 or 20 millimeters will do the job. So that's step number one. Now as we go through this story, we'll find that there's a couple different ways to think about associativity. In some ways, this whole problem could be solved simply by being more careful to create associative assembly models, so that when this part changed, its key mounting points would just automatically update. And that could have been done by a little bit more careful assembly construction. But we often find, especially in fixture assembly modeling, that associativity is overlooked or isn't taken care of, because in so many cases these fixtures really do not get reused. It's not all that common to come back and do this kind of work again. So in lieu of associative construction, we've got these other tools that can quickly get us a reusable condition. With that in mind, what we're going to do is move the bolts, which are obviously in the wrong position now, and position them correctly for this hole. But instead of moving the bolt itself, what I'd like to do is hide the bolts and move the holes. So again, we can move face. We'll select the hole itself. This time we'll pick up the coaxial holes that go with it. That should get us holes on both sides. And we can simply go point to point, move from the center of the hole as it exists to the center of this hole. That should line up the bolt with the holes on both sides. Now the hole is in the right spot, so we'll OK that. And when we turn the bolts back on, we can see that the bolts were actually positioned with associativity to the holes. So in this case, this fixture has been developed with kind of a mix of associative and non-associative techniques or procedures. In this case, we've moved the holes and the bolts have taken care of themselves through associative assembly modeling, but the hole was not associative to the part, as really was the key intent here for this thing. Next thing we need to do is to change the length of these bolts. So we'll make the fixture bolt the work part, and we'll move face again. In this case, it's a little bit trickier to do the selection, so we will invoke the new visibility see-through option, and this is really very helpful here. It's perfect for us. And we're going to move now this face, this face, and the face on the back, which is this one. We'll use point to point, selecting first the center of the flat of the bolt, and we'll move that to the outside of that flange. So the bolt has stretched, and we see that in fact it's instanced in both locations here, so that as we finish up, both bolts have stretched out appropriately and fit correctly. We can go back to our full assembly view and things look just right. So we've updated our fixture quite quickly. Get it all back visible. The bolt holes have moved. The bolts have followed it associatively. We've stretched out the bolts to fit, and we've made the whole thing taller to begin with. So again, using the same kinds of assembly modeling techniques that we used to fit this green part properly into its new airplane tail, we've now made the fixture assembly adjust to fit the green part, and then we can move on to machining.